Hi, my name is Ben Sanders. I'm interested in learning about machine learning and artificial intelligence. To that end, I've chosen a challenge for myself. I found this challenge at riddles.io, which is a website where you can create bots that play games uh, and submit them and have them compete against other people's. And the challenge that I've chosen from this website is the game of life and death, or GOLAD. First, a note on riddles.io. I think it's a lovely website. It is absolutely wonderful. It's very well put together. It has a lot of very interesting puzzles and games that you can try out. If you are a programmer who would like to try your hand at building an AI to play a game, or if you are a machine learning expert who thinks you know all there is to know, this is a great place to come and test yourself, and I would really recommend anybody to come and play around here. GOLAD, the game of life and death, is based on Conway's game of life. Conway's game of life is a fairly simple simulation. It starts with a grid of squares called cells. These cells can either be white, dead, or black, alive. Then, at each step, we will determine whether or not a cell is alive or dead based on some very simple rules. Any cell that has more than three neighbors, such as this one that I'm pointing at right here, who has 6 living neighbors, that cell will die in the next step from overpopulation. Likewise, cells like this one who are all alone, that's going to die from loneliness. And then there are cells like this one right here, who have exactly three neighbors, but it's not alive this turn. A cell will be born there from these three cells. And the point of Conway's Game of Life is to show that given a simple set of consistently enforced rules, we can see some very complex and lifelike behavior emerge from this system. And it's a fascinating topic in its own right. I would recommend that you research it. You can Google search for it, and they will even start a simulation for you so that you can see it in action. So that's really cool. Conway's, or the Game of Life and Death, as opposed to Conway's Game of Life, is played as a two-player game. You have a board that has blue cells and red cells, which represent the two different players. And these players are competing for the space on the board. And what you see, the simulation that you see playing out repetitively here, is not a very interesting example because we start with a mirrored image of the cells and then it just plays itself out exactly the same on both sides. Neither player is doing anything to the board to change things. And that's where the the bot comes in, where the artificial intelligence that is going to play the game comes in. So, looking at an old match I did, we can see the initial state of the board here. Now, we see more than just the current state of the board. We can also see the next state of the board using their visual representation. The cracked cells are going to die next turn. These two are lonely, and they're going to die. And these little cells here are going to be born next turn. Well, these are just going to stay alive. Each turn, a player can take one of three options. They can pass and choose to do nothing and allow the board to progress naturally, or they can choose any living cell on the board and kill it, or they can choose any dead cell on the board and create a living cell of their own type there, but they have to sacrifice two of their living cells to do so. There are two main reasons that I really like this challenge and why I chose this challenge. The first one is that I don't have any good way of evaluating whether a move would be a good move or a bad move. Let's say I was wanting to kill off an enemy cell, and I want to choose a cell that is going to really have a big impact on those cells on that team, and I really don't have a good way of being able to tell which cell I want to kill if I want to do the most damage. Likewise, if I wanted to birth a cell somewhere so that I could spawn a lot more of my own cells, it's not clear to me where I would choose to do that. The second reason that I like this challenge is that the search space is very wide. What I mean by that is that at any given step, at any given turn, there are a very large number of possibilities. There are a large number of possible moves I could make. So to begin with, here we have 80 living cells. That's 80 different moves that I could make as a kill move. I could kill any one of these 80 cells. I have over 100 dead cells. Every one of those represents a move that I could make to birth a cell. And for every one of those, I have every combination of 2 of my living cells that I could choose to sacrifice in order to birth that cell. This comes out to a lot of different moves that I could make, and no good way of being able to tell which moves are good moves and which moves are bad moves. I really like this because it's going to force me to rely on machine learning and artificial intelligence. I'm going to have to allow the computer to learn what moves are good moves based on its experience of playing the game. So to that end, I have built a testing area so that I can allow a bot to play a match against another bot in my own personal environment. And I have a referee that I have programmed that can run these matches and can also do round robin tournaments. And so if we take a look at that, we see here a match going on between two players, a couple of matches. Now these two players are completely stupid bots. They choose their moves completely at randomly among the available moves. And they're not very good. Neither of them is winning particularly more than the other. But we can see the game playing out here. This is a lot of fun. But it's not learning from itself yet. It's not learning from its successes and failures. In fact, it has no concept of whether winning is a good thing or a bad thing. And so we've got a long way to go from there. The next thing that I did was I created a couple of slightly more complicated dumb agents. A dumb agent is an agent that doesn't learn. So I took these and I put them into a round robin tournament and had them play 1,000 rounds against each other. The bots that I put up against each other are the completely random bot, a bot that chooses a random cell and to birth, and 2 random cells to sacrifice every turn, a bot that kills a random cell every turn, a bot that passes every turn and just skips its turn, and a bot that will choose an enemy cell to kill at random every turn. And I had these play against each other. And we see some interesting things. To a large extent, it's what we would expect. Kill E, kill the enemy, has the highest overall win rate of 77%. We see that the birth strategy is not a very good strategy. It only wins 24% of the time against the randomly chosen moves, and even lower against any of the others. Surprisingly, the pass wins a considerable number of matches against random. Uh, I'm not sure why that would be. We do see that the kill bot here wins 77% of matches against random, and the kill enemy bot wins about 90% of matches against the random bot. So, some pretty interesting things. We do see that the kill E bot wins 57% of matches against the kill random bot, and the kill random bot wins 25% of matches against the kill enemy bot. Now, that only adds up to about 84%, which means that about 16% of the time, those two are ending up in a draw. A draw can happen in two ways. One is if the game exceeds 100 turns for each bot, then it's declared a draw. Also, if all of the cells of both players are eliminated at the exact same moment, then that would be considered a draw. So, some interesting things. Still not doing anything interesting with machine learning, but this shows that I've got a solid test framework and a test bed where I can grow my artificial intelligence. I submitted my kill E bot to riddles.io, and it's got a few points. It's not doing the best, which I wouldn't expect it to do the best. There's not very many people playing this game, but all of them are doing better than just choosing a random enemy cell to kill. So I was originally disheartened when I saw that there weren't very many people playing this game because I thought maybe there wouldn't be any competition. I was afraid I would come up with something stupid like this kill an enemy uh, random bot and it would take me to the top of the leaderboard and there would have been no challenge. But I decided to go with this anyway because I could at least challenge myself against my own bots in my own test environment and try to beat my last best. But fortunately, what we're seeing here is that um, all of these people who are playing the game really pretty well. And just as an example, let's challenge the leader here, and we have to wait until after the match is played to view it. But you'll see it makes very short work of my kill random enemy bot. We see the game progress, and 5 rounds in, and Z-Bot destroyed me. So that's excellent. I'm really looking forward to the challenge of trying to overcome that. So for my next step, the next thing that I'm going to do is I'm going to create one more round of dumb agents. I'm going to create one that takes a random move, looks at what effect that will have on the board, and then when it runs out of time, returns what it thought was the best move that it had looked at so far. I'm going to make a bot that goes through every available move in order, one at a time, and evaluates what that move would do, and then returns the best move when it gets to the end of the list or when it runs out of time. And I'm going to create a bot that uses something called Monte Carlo tree search, which is an algorithm that has won a lot of game playing competitions early in the field of game playing AI. It's definitely a core educational algorithm that I need to learn about. And basically, what it does is it evaluates the moves, it evaluates how good it thinks each of the moves are, and then picks one kind of at random, but weighted towards those moves that are looking pretty good so far. And it looks at that move a little bit more closely. It simulates another permutation on that. But what if the enemy did this instead of that after I took that move? That type of a thing. And then it updates the value of that move and selects another move. So that should be a lot of fun. I would still consider that to be a dumb agent because it doesn't learn. It is more or less doing exactly what I programmed it to. It's just searching the space of available moves in a more sophisticated manner. I'm going to build that round of bots and I'm going to test them against each other and I'm going to submit the winner here on the website. And I'm going to do this because I'd like to have a benchmark against which my more sophisticated methods can be tested. So I want to get an idea for, what is about the best dumb agent I could come up with so that I can see how much or if more sophisticated methods would be better. Among those sophisticated methods, I'm considering things like using reinforcement learning on neural networks and that type of a thing. And so this should be a lot of fun and a big learning experience for me. And I'm really looking forward to this. So I will hope to see you guys next time, and we'll see how my next round of bots did.